Welcome to today's webinar. My name is Sebastian. I'm DevOps engineer for a couple of years working for Artix. And today I show you what can go wrong in the world of DevOps. All right. So let's start with a short statement. DevOps is a game changer. There are various people who might agree, but there are also a lot of people who say, come on, not again. It doesn't work. Why do you throw these buzzwords around me? For those people, I have to say, okay, I can completely relate and understand, since maybe you have encountered something similar, like illustrated in this cartoon from Monkey Users. I love these guys. When one person comes to a company and says, yeah, cool, your stuff looks so neat, so clean, everything is organized. Previously it was a mess, but after a couple of months it went to a mess again. So I hope you are in neither position of these two guys, but nonetheless, back to the initial statement, DevOps is a game changer if done right. And today I talk you what I've seen, what I experienced, and might give you some hints or insights how you can perform better. So after all, why bother? What is it all about? For me personally, first of all, it's a mindset. It's a question how you see it, how you work with it. And then second and third, it can offer you faster delivery speed. It can give you less pain for involved parties. So next, come on. So after all, the usual goals are communicated as yeah, improved deployment frequency, or gives you a faster time on market, lower failure rates on releases, and so on and so forth. I think you all heard of it and you are tired of it. I can say it can work, but after all, you have to have the right mindset to do so. Personally, I'm a great fan of try, don't repeat yourself. Personally, I think it's really a torture to do the same task again and again and again, since it's hideous and really straining you doing it. It can feel like this Sisyphus torture where he has to roll up a rock to the top of the mountain, only reaching it, it rolls back. And if you have tasks like those, or organizations, or processes which look like this, that you always have to do the same in slight variations, or it can be that you even have just one task you want to finish, and even before reaching the top you get interrupted, have to do something else, and you can never reach the top and have to start from beginning. I want to help you to avoid this pitfall, to get a less frustrating work. For me, the ideal work would more look like an assembly line, like this historical picture from the Ford assembly line, where for me, automation in IT is similar to an assembly line, since you have standardized tools, standardized parts, and standardized tasks. You are not even tempted to mess around with steps in between, because this stops and slows down your well-oiled machinery. So how to achieve this? Therefore, is this a classical DevOps cycle. I'm quite sure you've seen it in various variations. However, the core of it is true and stays true. At the beginning, you have to do a proper planning. What you want to achieve, what are your goals, how to implement it, not just go ahead and see what happens. Then, of course, you have to write your code. Doesn't matter what flavor it looks, what your product is. The procedures are similar. Like I said before, it's a question of mindset, not necessarily the technology. Of course, then you have to build your code, test it, and this is really a big part. Test what you have done, since early failures can save you a lot of time and a lot of frustration and pressure. Once the tests are successful, you do the releasing process like packaging, deploying, and once it runs, then you have to operate it. See how it behaves, look at it, logging, monitoring, you name it, and listen to what your user, customer, whoever this product is for, uses it and tells you what is their experience, what do they expect, what do they want, where is part of improvements, and you should listen to it, not only to business side, but also to engineer sides. If they notice, hey, this has a lot of memory leaks, deal with it. Then you have a thoroughly planning phase again, and the cycle repeats again. But as I said before, of course, you have to use some kind of tools. And with all tools, like illustrated with this hammer, it's a question, how do you use this tool? You can, of course, use a tool as it is intended by the manufacturer, designer, whoever, and you use it right. But sadly, not every tool is apparently as easy or easy to understand as a hammer, and you might use it wrong or not in a way it is intended, and this can bring you a lot of problems. In this tool, I give you some examples how you, or what I've seen, how tools could be used wrong and how you can do better. Therefore, let's start with some important concepts. First of all, the concept is called pet versus kettle. On one hand side, you have a cute little pet, which might be a kitten or dog, which you take care of. You listen to every problem. If it starts to feel sick, you run to a vet and try to make it good as soon as possible. You you really take great care. And yes, for cattle, on the other hand side, you have a lot of them. And on the other hand side, you really take care of them too. You take them to the vet and so on and so forth. But you want to have them in a unicized way. You want to have them treated equally. And yeah, that's the whole point or the whole reason between individual taking care and figuring out one treatment or one measurement which fits all. So going to IT, your kettle more looks like this data center, and therefore you have to find a way to find a common treatment, a common experience, a common denominator to use them all and to utilize them all the best. So what are the main goals? You want on one hand side to be fast. On the other hand side, you want to be reproducible or have a reproducible setup. So you don't have to do many minor manual steps. And on the other hand side, as cute as it looks, you want actually immutable conditions where your button, you don't want your machines to change or age. You want them ideally to behave on the second day as on the first day, on the 100th day. They should behave ideally the same. So, knowing this as a basis, how bad can it be? Usually I would ask in the round, yeah, come on, maybe you can give some examples yourself. In this mode, it's right now a bit difficult, but just to give you one small example. You might have used a container in a containerized environment, but if you start to treat your container with all these concepts and best practices and recommendations as your pet, like you're doing some individual treatments, individual changes, and so on, you might encounter unexpected behavior. For example, where are my data? I just changed the configuration file. It was running fine yesterday. Why doesn't it run today? Yeah, your container was restarted or rescheduled to a different node. And since you did the changes within the container instead of the image of the container, or you didn't do it on a persistent volume, your data are gone. You did it in a transient way. So this is bad. And I would recommend you to avoid this behavior. Like I said before, use your tools as they are intended to be used. Same goes in opposite direction. If you try to squeeze a huge monolithic application in a container, which has a lot of problems in itself, since a huge monolithic application has various components which you have to consider, be it ports, storages, or configuration files. They all have to be taken into account, and it takes you quite a lot of time to make it even run in the first place. On the other hand side, you also have to consider the resulting container will be huge. And usually, if you have your nodes or your hypervisor, there's a certain optimal amount. If you're running a container which is so huge that it takes completely a node or hypervisor, then you could have saved you the hassle. But on the other hand side, why does it fail? I spent days, months, whatsoever to make it work, and it fails again, and it fails again for various reasons. So therefore, think about it first. Think whether it's reasonable, whether it should be done this way. Are there alternatives? So my personal opinion is I'm a huge fan of the GNU principle. Each program should be doing one thing well, no more, no less. And this goes in the direction of the, so to say, trend of microservices. But of course, you can not only always have the choice. Therefore, I would recommend you, if applicable, use microservices. Of course, you don't always have microservices as an option. You might want to build customized images, for example, container or VMs or whatever, since this can save you a lot of time. I will get on this later on. You can also use golden images. This goes in the similar direction. And you can, of course, or should, of course, use configuration management tools, because there are always some scenarios where they save you a lot of time, they are idempotent, and can take you a lot of problems. After all, try to keep it simple. If something is so complex, so confusing, that you really have a lot of troubles managing or even understanding your stuff, then you might challenge it. Either you want to hide something or someone else want to hide something. And the more complicated, the more complex your process is, the higher the chance to have it fail, and the longer the time it takes to debug it and run it again. So therefore, try to have it in a reasonable, simple manner. Next principle, which I go on, is CI/CD, continuous integration, continuous delivery. This might look similar to the DevOps illustration I showed you before. And of course, they go hand in hand. At the beginning, you have the planning phase, like I described before, the build and code phase, which is continuous integration. Once you had your code, then the code will be built and tested. And if building goes wrong or the testing goes wrong, it goes either to the coding phase or through the planning phase. If it goes well, it goes to the continuous delivery part, release, deploy, operate. And operate, I mean again, having your monitoring, logging, and user or customer feedback. And as you see, the central part is the testing part. And this is a point where I want to go next. Like I said before, I'm a big fan of this monkeyusers.com. And here you have your test automation script here. This is our test automation script. You see the guy in the red shirt is the one of the QA, the one in the blue shirt is the dev. And testing goes way faster, way easier. It looks great, but at some point it fails because your product changed and developed. There was one tiny little new step, and it failed horribly due to this step. On the other hand side, it might be possible that you have your automation script. It runs well and runs well, but it does not detect the bugs, those cute little green ones over here. And this is another problem. If you have a test for the testing purposes and not a test to figure out what goes wrong or what potentially can go wrong. So for test automation, I would say you can go on various levels. You can have a linter, you can have integration tests, you can have unit tests, or actually the order would be the other way around. You can have, for example, Ansible molecule can help you as unit test. You can have different environments which help you as an integration tests. And you really should test at those environments and not directly deploy to prod and only deploy to a production environment once it goes well. So on the other hand side, what can go wrong? Well, your CI/CD pipeline can have outdated libraries, or each run processes a complete installation routine of all the components required for each individual steps. And this might take each iteration of the CI/CD pipeline like 10 minutes, 30 minutes and longer, Of course, it strongly varies on your product, whether it's some compiling action or some minor task. But nonetheless, if the same steps will be executed each time, you waste a lot of bandwidth and time. Then it might be possible that you have lagging tests, that those tests are not executed, or you have non-working tests where they might fail or might not fail, but you don't really care about them, or they worked ages ago, but for 2 years nobody took care of it. Or you have a lot of ridiculous steps to make the pipeline start. And if you do something wrong, the pipeline goes wrong, and so on and so forth. This should be automated. This shouldn't be a source of errors. So how can you do better? First of all, take care of your pipeline. This is not a once done product. This is really something which develops with your product. Your product develops, so your pipeline develops. You change required resources, you change required libraries, you change required tests, since there were some bugs you have to catch and have to implement tests for those bugs, and so on and so forth. So really take care of it. Next point, as I was saying before, test environment. So you had this can have a lot of pitfalls, like performance drop, production environment, lag kill, and so on. So what we have to say, it's important to have a proper environment. And what I've seen is that the testing environment will be skipped or omitted entirely, and it goes directly to production. And some excuses I've heard were it's like, yeah, it's a habit. It's just a quick fix, or urgent things need to be done, or there were no resources for testing. And then it starts from a temporary to a permanent solution. A friend of mine says a temporary solution lasts the longest, but nonetheless, this is not working. This goes horribly wrong, and know there are in the media enough stories where something like this went wrong. Those steps were omitted. How to do it better? First of all, back to the mindset, be disciplined. Second, plan your resources appropriately. It does not make sense if your testing environment is way too much sources to be useful for a product. It's completely fine that the testing environment does not have the same, but nonetheless, the testing environment or environments should have at least as much resources to do regular cleanups, to do regular change image or libraries or get properly. But first of all, think about it. Weeks of pressure and firefighting and unwanted conditions. Monitoring, going back to our kettle. Even though I said before and equally, and so on and so forth. But still, if some of those misbehaves or has troubles, you have to know as soon as possible, since the chance is high that the same problem occurs on the other ones too. And if you have it in an uniformized way, then you can deal with it before it starts getting critical. So what can go wrong there? There can go a lot of wrong there. First of all, you might have or get false alarms, which trigger you an alarm and saying, hey, yeah, something goes wrong. And then you think, hey, come on, this is not the case. What do you want from me? For example, if you have a computive intensive task and your monitoring says, yeah, almost complete usage of the CPUs, RAM, whatsoever, yeah, of course, it's working as intended. It uses the resources given, but I don't need an alarm for it. Or you have missing alarms, that something goes wrong and you don't notice why. Why? Oh, why again? Does it not work? Or you get a call of your law department or some higher up managers or whatever saying or complaining, hey, I'm losing money. What's going on? I want to continue my business. Why didn't you do anything? I didn't notice something. And you don't want to be in this situation. So then it might be possible that your monitoring database backend or front end crashes, or you try to heave or look at a time window which goes more than 2 hours, then your front end crashes, or your multi-line stack traces are not parsed together. I'm thinking of stack traces like Python or Java. They can give you a couple of lines at once. If you have really few applications which might throw this error, you might get with some trouble can paste, or you can paste them together. But if you have a number of applications, lot of logs coming in, and they are not parsed together, you start getting or spending a lot of time just getting the original error message before you can start debugging and fixing it. But how can you do better? First of all, only select meaningful metrics and logs. You don't really have to monitor what is the water tank of your coffee machine in a 1 second interval, so you know that you don't have to change it yourself or fill it up yourself. This is meaningless for mission critical applications. Of course, it can be mission critical whether you're ops developer or whoever does not get their coffee, but nonetheless, it's not business critical. Then it's also important to use optimized queries, or use dashboards, condensing your information to the most meaningful, or have a couple of dashboards which focus on certain aspects. The goal is to see immediately if something goes wrong and immediately know where to go next to solve this problem. But after all, the most important part, and I want to be agnostic about the application themselves, know your application. It does not make any sense using some application wrong and wasting a lot of money, resources, and in the end, working hours of you or your colleagues if you don't know how to use the application. Another point is, as I was mentioning before with the CI/CD pipeline, do regular updates or build regularly new images, be it a VM or container or whatever. The good thing is the more often you do, the less is the difference and the less time you have to spend on it and go the upgrading path and all these pitfalls connected to it. So then you might have just a couple of minutes to spend on it instead of a couple of days. Those might affect your mission critical applications if they're left in an unusable state. So like I said, regular updates, and as a nice side effect, you get a better routine. If you deal daily with your applications which needs to be updated, you know where are the pitfalls, you know where to look at, you know where how to deal with it. The best case, you use automated updates in a automated fashion, be it within CI/CD or configuration management tools. It depends on your environment. Nonetheless, those save or reduce the human errors. Humans are not perfect, neither you nor I. At least I know from myself. But if it's automated, then the chance something goes wrong on my hand or on my colleague's hand is reduced quite a lot. Like I said before, less effort with fewer differences. Another problem which I regularly encountered, and which is going back to the mindset topic, work in silos. Yeah, just a small comic to illustrate this problem again. Yeah, sorry, not this department's responsibility, or wouldn't have a clue, try another division, can't help you, not our problem. And each of those departments, the bigger the company, the more departments you encounter and have to work with, the more it's likely that it can happen that they say, okay, it's not within my scope, not my problems, I have enough on my plate, try it yourself. This is really problematic, but how to do better? Talk to each other. Talk to each other in your department, with the guys or ladies from the other departments. A good friend of Artix, Martin Alfke, who is a trainer for Puppet, and we worked for years together with him. He always recommends if there's a smoker's break or coffee break, try to join them. It doesn't matter whether you rather drink tea or just want to get to the air. Just doing some small talk with these group of people. Best case in a mixed department session, not only your department, you get to know each other better. You might get good insights who to talk to, how to can speed up some processes, and so on and so forth. But this interaction does not work from itself. You have to do some networking, so to say. So another problem in general manner is are inefficient constructs. For example, I'm a great fan of Ansible, and you can have unnecessary Ansible loops. For example, if you say with Ansible package or yum or apt install package ABCD, you can on one hand side hand them over completely as one string in the end or one list to the target machine, which goes pretty fast. Or you can do it wrongly and say, okay, what you wrote is a loop, and then it will be sent to the target machine in a loop manner. So do, for example, update blah and apt install A, then again do a apt update and apt install component B, and so on and so forth. Obviously, the latter one will take way, way, way longer than the prior one. Therefore, going back to what I said before, know your applications. The same goes with a container, which install a set of components at each run. This is completely unnecessary. You, in best case, you spend once a couple of minutes building your customized image, which is ready to use instead of wasting your bandwidth and time with the same running routine each time. It accumulates too fast that you're wasting too much time on those unnecessary actions. What can help too is using optimized mirrors. Try to use some mirrors which are closer to you, or your local mirrors, or some less loaded mirrors. This can save you a lot of time. For example, I'm here in Germany. If I use German mirrors, it's way, way faster than using some mirrors in Australia or New Zealand or I don't know, Brazil, whatever. Try to think about it. Another problem you might encounter is the secret management. Over there, it's again the problem with the mindset, with talking about, with talking to each other. Best part of security is the more you want to do it, the less you need it. Because if you just treat it poorly, you get horrible problems. And this again, does not say that there are some people incompetent. It's really important that the people work together, that they know, okay, my application uses a database connection. The database connection has to be secure. My application has a front end, the communication to the front end has to be secure. There has a proper way of authentication and authorization and so on and so forth. You can go endlessly with it, but to save time, I can say some bad examples. For example, you have static passwords or even listed ones where the manufacturer themselves blacklisted certain default passwords since they are too commonly used and too insecure, or you even go the direction of using a proper key store, but you don't use it right, or you don't utilize it at all. You just have it lying around somewhere. It's better to have a script which has automatic generation and insertion of keys in key stores. Depending on the company policy, it might even go in the direction that the user or developer themselves don't necessarily know the passwords unless they have some permission or some short-term permission to get this password. But the less people the password know, the lower the risk the password will leak, and the less in the end the risk that your company loses data. And that pipelines only use key store keys. But again, if you use a key store, use it right. I encountered regular tools doing the same thing. This sounds stupid. Think about it. Look closely on yourself. Think it. Do you have only one source of truth about ticket management? Your code, or how the code is dealt with, or how the machines in the end. And the more redundant it is, the more this is the right place, and then you get drifts. You can have very of resource of the server is overloaded and others memory intensive applications. CPU is not used, and so this topic. But again, know your application, deal with it appropriately. As I said, know your application. Even though it might be obvious for the developer how to use this application, what you in the end encounter in production and see from user stories, user experience, how the product is used, it's really difficult. Therefore, you have to interact with your customer, client, whatsoever, and try to make it best. And maybe you can have a training or read through the documentation again. But this is a bidirectional problem. On one hand side, it might be difficult to get as a user the right information. On the other hand side, it can be also be difficult for the developer because they are in a certain information bubble and don't get the feedback they need. Documentation. This is exactly the point which I meant. Sometimes the documentation is just too poor or non-existent or outdated, and you should spend time on it because, let's face it, it's faster writing a documentation than getting 20 times a day the same question about the same problem, which could be dealt with a quick Q&A section. Knowledge items. This is the other problem, that you have certain staff members which know a certain tool, technology whatsoever well, and others don't. If this person is on vacation or has some personal problems and is not available, then some parts are completely stopped. The best way to deal with it is to talk to each other, try to do pair programming as knowledge sharing session, or try to get trainings or experts. Let's say it's again, communication is key. And with this, I want to sum up it again. Communication is key. So within your team, between departments, maybe even the team to higher ups to management, that the management knows what is the situation on the people who work with this product, that they know how to plan appropriately, not to overload them. Same again, like I said before, know your tools. Like I said in the beginning, DevOps is a mindset. Communication is the one important key factor. Know your tools is an important key factor. Knowledge sharing, documentation, trainings, and plan your stuff and regularly challenge it. But after all this information, you can do it. And if you need support, we are happy to help you with various kinds of levels, information, trainings. Just get in touch with us. Thank you.